Okay, now let's look at the box-Cox transformation, the cube root type. And once again, we're going to use the LES model for this. Well, let's start with 0.2 and 0.3 as the initial trial values. And here we can do it like this. So we take the value and then we can use the power function within brackets 1 over 3, that will give you 1/3, or same 1.729, you can use this function, power function, and that also will give you the same transformation. Copy that. Okay. Now we're going to use the level LES model. So let's use copy function from here. So including the error. So let's copy those. Okay, so now we need to make sure that this is done properly. So that's good. This is good. Okay, and this is the sum of these two, and that is E119 minus that. That's good. Okay, now level is F118. Okay, so here we have to change the alpha value to 112 instead of C85. So then the rest is good. Okay, C112, and the rest is good. So here, once again, previous trend, and that should be 113. Okay, then F119 minus H119. So that's good. Now we can copy these, put the border back. Now to bring the forecast from here, this is cube root model, so which means that should be 1/3, not so 1/3. Okay, you can take this and use power of 3 with that shift 6 caret symbol. That will take us back to 13.5, or you can use the power function like before. So you take that and use comma 3, and of course then you need to reduce the number of decimal places. Okay, you get the number back to the original value. Copy that. Okay, and then set up the accuracy measures like we have done previously. Okay, so there, and MASE be similar function. Okay, now we can run solver data, solver reset all, and now this time make sure that you're selecting the correct RMSE value for cube root model. RMSE, okay, minimize, and cube root model alpha and beta. Add alpha and beta less than or equal to 1, and we solve. Click OK. Now we have the best alpha and beta values. So that's the last transformation. Now let's assemble these accuracy measures for each of the transformations that we saw, and the original, of course. Starting with the original, the 4 different transformations that we looked at. For that, if we set up the RMSE for each of the models, we'll be able to copy the rest of them. So the first one is H24, okay, right there. So the rest of them are right below it, so we will be able to copy. The next one is K105. I'm sorry, not K105. So the next one is K51. So that's K51. And then H78 and so on. So once you assemble the RMSE values, then you can copy down and that will give us the rest of them. And we can convert the MAPE values into percentage. And now we can, okay, so we examine the summary of accuracy measures. And as you can see here, nearly all of them at least beat the random walk. Okay, the cube root and square root, the Box-Cox transformations are not doing very well, but the other three models that we developed are really doing much better than random walk. And then you look at the RMSE values, and it looks like the original model, LES model, without any transformation gives you the best results. So there is no need for transformation. But in any case, this example illustrates how you do the transformation to check it out. You have to check it out and make sure that you're not missing out on minimizing the error measures if you could do transformations.